Today I'm going to give you an introduction to ChatGPT and explain how the AI tool that everyone's been talking about was actually created. But I'm not going to teach you myself. I'm going to let ChatGPT teach you. Hi, I'm Brian Amrine with Value Driven Analytics, bringing you at least one training video on analytics, data science, and leadership concepts each week, so please consider subscribing. When I was thinking about creating this video, I originally thought, why would anyone want to watch me ask ChatGPT some questions? Why wouldn't they just ask ChatGPT themselves? But then I remembered the millions of viewers who watch people play video games on YouTube each day. So I'm going to use my 13 years of experience in analytics and data science to ask ChatGPT some thoughtful questions about how it was trained. In the process, we'll learn some basic and advanced data science concepts. If that sounds good to you, let's jump over to ChatGPT. All right, are you ready to have some fun? Are you ready to learn about some data science concepts and ultimately how ChatGPT was created in the first place? Well, let's ask ChatGPT that very question. I'm going to click on New Chat here, and I'm going to ask, how were you created? Let's see what it comes up with. It says I was created by OpenAI through a process called machine learning. And if you've been watching the channel, you might have seen that we have an entire video, a deep dive on performing data science, which is a higher level category that machine learning would fall into in Python. And we create regression models, a parametric model, and a non-parametric model, random forest, which is one type of machine learning model. So if you're interested in really diving deep and seeing how you can code out a machine learning model, and in that case it's to predict college football game scores, which is pretty neat, consider checking that out. And speaking of code, you can actually ask ChatGPT to create some usually just starting code for you as well. So that's another neat use case. Usually you're going to have to adapt it to your use case and make it more specific, but it does a pretty good job of giving you at least some high-level code to start with. If you needed to create code to send an email from Python, for instance. So consider checking out those capabilities too. Maybe we'll do a future video on that. Specifically using a variant of the transformer model architecture known as GPT, General Pre-trained Transformer. Here's a simplified overview of the process. So first it's telling us a little bit about data collection. It's got a large data set. I think this is sometimes called a corpus of books, websites, and other written materials. So all these sentences and words together. Then it's going to train on that. It says it was trained using a process similar to teaching a child to read and write. Thank you for making it simple for us. The training shows examples of text, teaching me to predict the next word in a sentence. Okay, so again, for those of you who have seen the data science training that I do with the college football example, you know that the three questions when you build a model are, what does one row represent in your data set? I'm still not sure, based on this description, what one row represents, so we'll try to get down to that and ask some follow-up questions as we can with ChatGPT. But it sounds like when it talks about predicting the next word in a sentence, that the target variable in this model is the next word in a sentence. Pretty interesting, huh? So hopefully it'll tell us, and it looks like it does, given the words that come before it. So I'm picturing a data set where the target variable is the next word in a sentence, and the input variables are the words that come before it. Now, that has to be a complex process because, again, if data science training, we talked about how with most platforms, a lot of times your input variables need to be a number. And so there must be some method of translating all these words that could come before it, and maybe it only looks back so far, but turning those into numeric attributes, that's a complex task, I'm sure. So maybe we'll learn more about it here. This is done iteratively and on a massive scale using powerful computers. I'm sure they are powerful, especially when you're learning on such a large corpus of data. Okay, it has some information here about learning patterns and relationships. As I process more data, I learn patterns in language, such as grammar, syntax, facts about the world, styles of writing, and it's inferred, right? It looks at it's learning based on experience, based on true text. Fine-tuning and testing. After the initial training, I undergo fine-tuning and testing to improve accuracy and performance. This sounds like a neural network algorithm, especially the fine-tuning and testing to improve accuracy and performance. It sounds like the backpropagation process in a neural network. Now, it did say it's based on a generative pre-trained transformer model architecture. So I'm going to ask more about that. Tell me more about the general pre-trained transformer algorithm. Okay, it's an advanced algorithm used in natural language processing. So that is the natural language processing is the big bucket of understanding and generating text. And again, within that, there are large language models. This being one of them, ChatGPT, and I guess it's using, imagine, a more specific technique, generative pre-trained transformer. And I'm thinking this is a type of neural network, but let's see if it gives us more information about that here. Okay, it's part of a broader family of models known as transformers, which have revolutionized the way machines understand and generate human language. Okay, here's a more detailed look. Okay, transformers, it says GPT is built upon the transformer architecture. And it looks like it was created in 2017. Significant shift from previous models due to the ability to handle sequential data like text more effectively. Absolutely. Text is sequential, right? And you need to understand the order of words to know what comes next. Apparently, what comes next, the word that comes next, is what it's predicting here. And it's telling us about this attention mechanism that seems to weigh the importance of different words in a sentence. Helps the model understand context and the relationship between words, no matter how far apart they are in the sentence. Neural networks, especially deep learning neural networks, have the ability to have your input variables, but then there's these hidden nodes that are calculated versions, combined versions of all of those input variables. And so that's how it's able to bring different words, different input variables together and kind of look at them in a combined manner. So I'm really thinking that behind the scenes here is a neural network model. I'm just going to ask it flat out here, is GPT a form of neural network? See what it says. Yes, generative pre-trained transformer is indeed a form of neural network, specifically a type of deep learning model. Again, that's where there's hidden nodes. You have your initial input variables, but then it creates variables on top of that based on combining those variables together. So let's come back here. Neural networks are computational models inspired by the human brain, hence the term neural networks, backbone of modern artificial intelligence systems. So when you think about AI, that term gets thrown out so much, and it means different things to different people. To some people, data analytics, just making decisions based on data, is AI. To others, they would say absolutely not. But then they'll say maybe data science models. Maybe they think regression is because you're learning from the data and using an algorithm. Maybe they consider regression to be AI. Others would say, no, that's statistical learning, that's parametric models. You kind of have to tell it what variables to include, unless you're using something like forward selection. Machine learning models, though, like random forest and gradient boosting and so forth, those are machine learning models. And some would say, well, that's just machine learning. I think everybody would agree that something like ChatGPT, based on a complex neural network, and probably other types of tasks like you can use neural networks for image detection, to be able to say what's in an image, or sound recognition, what song is that, like some apps do. I think everyone would agree that that is considered artificial intelligence. It's this deeper level. And again, I think deep learning is a good explanation for it, where it isn't just automatically selecting variables, like I would say, automating the feature selection process in a model build, like most machine learning models would do. It's not just doing that, it's actually creating additional variables through this deep learning hidden node process. So I think that's where AI is differentiated. When you think about artificial intelligence, it really, especially if you use the most strict definition of artificial intelligence, you get down to these neural networks that are finding, obviously, as we've seen, some pretty deep insights and being able to do some pretty complex tasks using neural networks. I consider that to be AI. All right, well, giving us a little more information about neural networks here. Composed of layers of interconnected nodes. We talked about that, these hidden nodes, your input, you've got your input variables, your first layer, and each connection between neurons has an associated weight. So you can imagine all of your input variables, maybe it's different words in a sentence and different orders, those are being aggregated to create new variables in the next layer. So then, and a weight is assigned to each word, which adjusted during the training to optimize the network's performance. This is the refinement for accuracy. Eventually there's a backpropagation process that goes on where you use the weights that were determined, but then you kind of tell the algorithm tells whether those weights were good weights and tries to update them accordingly, going backwards in the process, going from your final prediction all the way back to your starting input variables. Learning through a process called training. Training is a pretty generic term that we use for training any kind of model, even regression models. Neural network adjusts these weights based on the inputs they received. Okay, similar to how a human brain learns from experience. It's a good analogy. When a neural network has many layers, it's called a deep neural network, right? So it's not just the input variables lead straight to a prediction. There are layers in between. It's creating variables on variables on variables in these hidden layers. This depth allows the network to learn complex patterns. When these variables are combined with each other, that's where the complex patterns are learned, which is why this field is known as deep learning. All right. So then it's telling us a little bit more about the GPT neural network, that it's specifically designed for handling sequences of data, such as text. And it makes sense, right? One word leads to another, leads to another. It's definitely sequential. Unlike earlier models that process sequences in order, transformers process all parts of the sequence simultaneously, which allows for more efficient training and better handling of long-range dependencies in data. Very interesting. Okay, so your word at the beginning of the sentence can be associated with a word at the end of the sentence in a more flexible manner, it sounds like. In GPT, the transformer architecture consists of multiple layers, each containing a self-attention mechanism in a neural network. Now it actually mentions here that there's actually two phases in the training process: a pre-training process on a large corpus of text, which is considered unsupervised learning, and then ultimately the supervised learning part, I guess that would be predicting the next word here. Now I want to confirm my assumption that the target variable in this neural network is the next word. So I'll just ask that question flat out. Is the target variable the next word in a sentence? Yes, in the context of training models like GPT, the target variable is indeed the next word in a sentence. Great. It says the primary objective, predict the next word in a sentence given the words that precede it. So let's confirm now the input variables as well. And of course, you could read the rest here. These are just some questions to get you started. What are the input variables in the model? And sometimes these are called feature variables or independent variables. A lot of terms for the input or independent variables in a model. And I think it should be the words that precede it. So let's see what it says here. In models like the GPT, input variables are typically sequences of words or tokens from the data. these inputs are processed in a specific manner to make them suitable to the neural network. So it looks like it starts with a process called tokenization. It takes that raw text, breaks it down to smaller units. So they could be words or parts of words. So at this point, it's still text, it sounds like. But this first step in the feature engineering process is to take those maybe sentences or words and break them down into smaller chunks. And then it gets turned into a numeric input. Remember, a lot of platforms like Python, beyond, depending on the algorithm, they don't take directly qualitative information. It's got to be coded out as a number. And some forms of algorithms might code it into a number automatically behind the scenes. At the end of the day, the input variables need to be numbers. So it looks like that's what the embedding process does. It says each token is then converted into a numerical form known as embedding, and they're vector representations that capture the semantic and syntactic essence of the token. So what I'm reading here is the tokenization that takes this sentence, turns it into smaller pieces, words, parts of words, syllables even, and then it takes those, turns them into numeric form. And then I believe that eventually the algorithm is going to start combining those words together in the hidden layers of the neural network. Another interesting thing I found here was that it also includes some indicators for the position of the word, like whether it's at the beginning or ending of a sentence. So it knows that position as well and can use that information to kind of make sense of it. Again, with the ultimate goal, predicting what word comes next. So we talked about the target variable being the word that comes next. We talked about the input variables being preceding words once they've been tokenized and once they've been embedded, turned into numeric form, and combined together in the deep learning nodes. Well, the next question we want to answer when we're building a model is, what does one row represent? Perhaps the first question that we want to answer, really. But those three questions. So we know the target variable, we know the input variables. Now let's ask ChatGPT what its definition of one row is in the training data set. What does one row represent in your training data set? This will be interesting. In the training data set for models like GPT, one row typically represents a sequence of tokens, words, parts of words or characters derived from the text. Each row is structured to provide the model with a snippet of text to learn from. Okay, and then it tells us a little bit more about that. Let's just skip to the example here. Consider a large document. During pre-processing, the document is broken down into sequences of tokens. Each sequence that fits within the model's maximum sequence length is a row in the training data set. So it sounds like you can't have too many words in order, but maybe every set of 5 or 6 words is kind of what I'm thinking, or whatever its maximum is, and the maximum is probably a lot more than 5 or 6 words. For example, if the maximum length is 512 tokens, okay, so token is a word or even a syllable, depending on how it's broken it down. 512 tokens in a row. Each row in the data set will have 512 tokens, or fewer if padded. By training on these rows, the model learns the relationship and patterns in the sequence of tokens. Predicting the next token. Each row is used in training the model to predict the next token in the sequence. So it sounds like it could be the next word, but it also mentioned a token could be a syllable. So in some cases, it might just be predicting the next syllable, perhaps, which is a fundamental aspect of how models like GPT learn to generate text. In summary, each row in the training data set for a model like GPT is a carefully structured sequence of tokens designed to provide the model with meaningful linguistic context. Okay, so it's not really directly answering that, other than it sounds like it's almost like every order of 512 tokens in a row. So imagine after the tokenization process, this big document, a large text document, It starts with tokens, or if each token happens to be a word, for instance, the first 512 words would be one row, and then perhaps word 2 through 513 would be the next row, and then perhaps row 3 through 500 through word 514 would be the next row, and it just keeps going through the document until it gets to the end. That's what I'm envisioning based on this explanation. Maybe I'll just confirm that here. So if we use this example, a large text document with 514 tokens and a maximum length of 512, we would have 3 rows in the training data set. Is that right? This will be interesting to see if it can take this example and understand it. 514 tokens, and are using a model with maximum sequence length 512. The way these tokens are divided into rows, training data set depends on the specific approach. Okay, so approach 1, splitting without overlap. In this approach, the text is split into segments of 512 tokens each. Without any overlap, you would have 2 rows. Okay, the first row contains the first 512 tokens. The second row contains the remaining 2 tokens. So it just uses 512 and then the next 512. Okay, so now it's walking through another approach where, again, you start with tokens 1 through 512, but in this case there's at least some overlap, but not to the extent that I was thinking, where it would then start from 2 to 513 and then 3 to 514 and so forth. So I'm wondering how a row with tokens 1 through 512, what the target variable would be. Would the target variable simply be the last word there, and you're using all the previous rows to predict that? But I'm wondering why you wouldn't take that first row with tokens 1 through 512 and turn that into, probably 511 to 512 different rows, each one predicting each one of those tokens. So in this example of the first row containing tokens 1 through 512, I'm wondering if it somehow breaks that down into individual observations where each token is a different target variable. So I'm going to ask that question. In the example of the first row containing tokens 1 through 512, which token would be the target variable? Let's see what it says. In the example, first row contains token 1 through 512, which is trained to predict the next token in the sequence. The target variable for each token is the subsequent token in the sequence. Okay, for each token in the input, except the last one, the target variable is the next token in the sequence. For instance, the target for token 1 is token 2. So it sounds like it really is one observation, or perhaps what's happening is the way you build the model is you feed it a set of tokens, 512 tokens, for instance, and then behind the scenes, it is breaking that down into individual, in this case, 511 training observations. Yep, here's a good picture here. In essence, each token serves as an input for predicting the next token. Okay. So this one row is essentially 511 training observations. Maybe it's just semantics. When I think about training observations, that's what I think of a row being. Is that right? Okay, yes. In the context of a training model like GPT, a single row of 512 tokens can indeed be viewed as providing 511 individual training observations or input target pairs. Okay, so it sounds like it kind of sees that set of tokens as one row, but really behind the scenes, that is 511 training observations, each with its own target variable, which is the next word using the preceding words. Very interesting. If you're an expert in large language models like ChatGPT, please let us know in the comments if there's anything I'm misunderstanding here. But I feel like I learned a lot and have a really high level, surface level understanding of what's going on in ChatGPT here. I hope you got a lot out of this session today. I certainly did. And if you did, please consider gently pressing the like button. You know, people, especially YouTubers, are so hard on the like button. Everybody's always talking about hitting the like button and smashing the like button and even sometimes destroying the like button. Why are people so hard on it? The like button is a great thing, especially for YouTubers. It can help our videos be seen by a wider audience. So please, I implore you, press the like button, but do it very gently. Be nice to the like button. Finally, if you'd like to see more data science and analytics trainings, maybe even some future ChatGPT trainings, please consider subscribing to our channel. That's it for this training, and I hope to see you in the next video.